If you look at the 10 gigabit module evolution, back in 2000 was the first module. Prior to that, it was all customized designs. And the module was a fairly big size module. In fact, the one was about a 12 by 10, something like that. It went down to a 5 by 7, and they have clean interfaces defined for the equipment guys to do their designs. That quickly moved into pluggables in the data side. And Cisco was a big pusher of this, of having X-Pack, X2s, Zen-Packs, and they both were different form factors. One was smaller than the other. Again, this is the pluggables in the enterprise networks between the switches. And then you look at the density. XFP was really, SFP was one of the first ones telecom adopted. XFP was the next. And it was quite a struggle to get it into the networks, but soon you had no choice. To get the flexibility and the cost, you had to put these pluggable modules in and call the trade-offs between design with your network as it grows. And then density coming in, SFP plus is the next one coming in, and then there's another one, SFP plus, double density. So you can see what's happening is they're getting smaller, less power, and cheaper. But there's another key factor that we can't forget is during this evolution, there was designs being done on the system side of the house to take certain functionality out of those modules. So a trade-off back and forth, how much functionality you leave in the module versus the system design. And again, it was a cooperative effort to really get the lowest cost solution. If you look in the 40 gigabit market, jump to the bottom, there's really 3 formats out there today, and each one has its attributes. DPSK is the lowest cost, DQPSK is the second lowest cost, and 40G coherent is the highest price. Now again, that's starting today. Clearly, those have to come down in cost, price, to really get the market to take off, and the market is dependent upon when you get those cost thresholds. So if you look at that, we feel emerging markets, new builds right now, we see 40 gigabits going in. DPSK, DQPSK, picking which format you want depending on your application. Clearly in China and Japan, we see continuous growth in the 40G area. And then we see Europe is still weak in general and migrating some of the backbone networks into these mesh configurations, metro configurations. So we see 40 gigabits is going to be around quite some time. And again, it depends on the cost differential between 40 gigabits and 100 gigabits. But there's quite a difference right now when you go across these different formats. The R&D investment right now, again, 40G is where 10G was, where a lot of people are investing in parts and digital devices. As they come in and we get multiple suppliers in those, the prices will come down. So we're counting on 40 gigabits as going through an evolution very similar to what 10 gigabits is. And then, of course, the trade-off is going to be when you get to 100 gigabits for the core, when does it take off relative to the 40? The 100 gigabit market is kind of different. In 40 gigabits, we clearly went to module base. 40G coherent, some system vendors built their own, customized it. It's kind of going back where it was when customization was done 12 to 15 years ago. So there are some system vendors that have built 40G and 100G coherence into their systems to get to market early. And so that's about half the market in the 100G range. We think that that eventually will evolve, same as 10G did, and 100G will start to come out in a modular format, and some customers will adopt it as they go on to the next generation. And you just really can't keep up with the technology. One design is not going to last forever. So you must take it through an evolution path, and because these devices now, I sometimes refer them as moon rocks. They're very expensive. There's only a few suppliers of them, but they are starting to get standardized now, and the cost will come down. And really the 100G coherent modules will grow over time really because it simplifies the network. In the core backbone, it simplifies the network, You see 100G pipes coming off the routers right now. They're going to feed into these directly. You don't have a lot of aggregation type issues. And I look at the kind of 4 advantages, and there's many more than this. Probably can bring them up, but clearly 100G going directly into a 100G network is much more efficient for the endpoints, the routers and that. Link aggregation costs money. But again, right now 10G is down a tremendous evolution curve, and 40G and 100G have a ways to go. You certainly get spectral efficiency, and you eliminate all the dispersion compensations needed. But it can't coexist with, you have to engineer it around PSK type routes. And then module evolution, again, the client side is going to go through a density package again. We see it coming already. It's a CFP package now, 4 times that density, and continue to go on up to 32 times that density. These are multi-wavelength solutions on the client side. So they're going to continue again down a path very similar to what the 10G did. On the line side right now, we see it going into a pluggable, into a CFP package, but quite frankly, it's not here today because these are 80-watt type designs. There's a lot of power, and they have to come down as the technology evolves. But this is the first time, by the way, in a 100G coherent design, we used to design optical networks. It's brute force optics, how much can I get out of the optics? These designs are based on the fact that you have digital trade-offs with the optics designs to optimize it. So you get much better performance, and then you're on a digital curve to reduce the cost. My takeaway thoughts are, we believe the market is coming back, starting to grow again. I think it's going to be, where it grows is highly dependent on where the costs are. We think that most of the module manufacturers are going to have to do vertical integration to be competitive. It's just the fact that, like, you need some, you're not going to compete against, I'll call it an assembly manufacturer, if you don't have core competence, core content in those modules. We have a challenge on our hands because, again, you have system vendors who have gone in and done custom designs. So what is the trade-off to get them to move from the custom designs into using your module design? And I believe it's cost. It's the evolution of the technology that hits the right cost points and says put this in. The 10G, both telecom and datacom, we see as a healthy market right now, still growing. XFP tunable, which is going to allow us to get into the ROADMs and that, will continue to get out of the fixed wavelength. Its cost is getting approaching fixed. And as it approaches fixed, you'll see us start to replace it out. So, and the performance is pretty good on this stuff right now. It's a small package. Again, you plug them in as you want them. So we see that going to take off. And then it was announced that, of course, SFP Plus package, which is a much smaller package, there's also tunables being designed for that. So you can see it's really adding a lot of flexibility into the networking, which drives cost down. You know, if you have to keep spares for every wavelength you have on a backbone system, it's very expensive and usually is a delay when you turn on service. The 40G trade-off in the metro area, I think 40G is going to be around a long time in the metro area because 100G pipes are just too big for that right now, too expensive. And then the client-side deployments, we're already seeing that being deployed now. There are a few spotty 100G coherent applications being put out there. We see the same thing's going to happen next year. And by 2013, we'll have multiple suppliers. We'll start to see the market take off. I think, again, on the bottom one is the same thing I said before. It's pretty exciting because it's no longer just an optical house designing something that's going to have the performance. You now have to marry your expertise with a digital processing type thing to really get the right performance and reduce the cost. Because optics can't do it by itself anymore. Okay? That's it.